Your production infrastructure should change only when Git changes. Let that sink in for a second. It's a really simple idea, but it's one that completely flips the script on how we manage complex tech systems. Forget about manual tweaks, late-night SSH sessions, and random scripts that nobody can trace. What if every single change to your servers, your clusters, your apps was as clear, as auditable, and as easy to roll back as a Git commit? Well, that's the core promise of what we're diving into today.
In this explainer, you are going to get a crystal clear understanding of what GitOps actually is, why it's such a big deal, and how it works in the real world. We're going to break down the philosophy, the mechanics, and exactly how this powerful framework gets used.
This is AI Tech Sheet Code, breaking down modern tech without the noise.
So here's our game plan. First, we'll look at the absolute chaos that GitOps was designed to solve. Then we'll get into the core solution, how it actually works under the hood, where you'll see it in the wild, and of course, the common mistakes to avoid. Let's jump right in.
You know, to really get GitOps, you first have to understand the world it was designed to fix. A world full of manual changes, untraceable errors, and a whole lot of stress.
Let me just ask you this. If someone on your team pushed an update to a production server, say 10 days ago, could you tell me right now exactly what changed, who did it, and why they did it? In so many traditional setups, the honest answer is a panicked, I have no idea. There's just no version control, no real audit trail for the infrastructure itself.
And that leads to what I like to call the pre-GitOps chaos. It all starts with something called configuration drift. This is where your live environment slowly, silently becomes different from what you think it is. And why does this happen? Usually because of manual errors, a little typo in a command, a quick hotfix, which are basically impossible to trace because there is no audit trail. And this whole situation creates a culture of cowboy engineering, where engineers making quick, undocumented fixes directly in production is just, well, normal. It's a recipe for a fragile and super unpredictable system.
Okay, so that's the mess. How in the world do we clean it up? Well, that brings us to the solution. And the core idea is actually kind of genius in its simplicity. What if we treated our infrastructure with the exact same discipline and best practices that we already use for our application code? So what is GitOps? Officially? Well, it's an operational framework. The best way to think about it is that it takes all the good stuff we love from DevOps, version control, working together through pull requests, automated pipelines, and just applies all of it directly to managing our infrastructure. It's not some DevOps 2.0 buzzword. It's a very specific and very powerful way to do DevOps the right way for your entire system.
And this right here, this is the heart and soul of it all. The entire desired state of your system, every server, every Kubernetes service, every single network rule is described declaratively right inside Git. Now, declaratively is a key word. It means you don't write scripts that say how to do something. Instead, you write configuration files, like YAML, that just declare what the end state should look like. And just like that, Git becomes the one and only source of truth.
This whole philosophy really stands on 4 pillars. First, as we said, the system is declarative. You define the what, you let the system figure out the how. Second, that state is versioned and immutable inside Git. This gives you a perfect, unchangeable history of every single change ever made. Third, and this is a huge deal, changes are pulled automatically by software agents living inside your infrastructure. This means your cluster doesn't need its passwords exposed to the outside world. It pulls the updates itself, which is a massive win for security. And finally, here's the magic part. The system is continuously reconciled. These agents are always watching, making sure that reality always matches what's written in Git.
Okay, so that all sounds good, but how does this thing actually work? Let's get into the mechanics. We're going to pop the hood and look at the automated reconciliation loop. This is the engine that makes the whole thing go. The whole process kicks off just like any other code change. An engineer, developer, operations, whoever wants to make an update. Maybe they want to scale up an application. They don't SSH into a server. Nope. Instead, they just change a line in a YAML file in a Git repo and open a pull request. That change then gets reviewed by a teammate. Just think about that. You now have peer review, collaboration, and a formal approval process for your infrastructure, just like you do for your code. Now, as soon as that pull request is merged, the automation kicks in. You have a GitOps agent, a tool like Argo CD or Flux that's always watching. First, it detects the new commit, like the instant it happens. Then, it compares this new, desired state from Git with the actual state of the live system. It's basically playing a constant game of spot the difference. Finally, it syncs. The agent pulls the new configuration and applies it, automatically bringing the live system in line with the source of truth. All of this with zero human intervention. What you get is this powerful, continuous reconciliation loop. So what happens if a hacker, or even just a well-meaning engineer, goes and makes a manual change directly on the cluster? The GitOps agent sees it. It detects this drift, sees that the live state no longer matches the Git state, and it automatically reverts the change. This is like giving your infrastructure an immune system. It's constantly self-healing to match its true intended state. It's a game changer for security and stability. If this is making sense so far, do me a favor and give the video a quick like. It really does help out the channel.
Alright, so the theory is solid, but is anybody actually using this stuff? Where do you see it in the real world? Let's take a look at GitOps out in the wild. Okay, so the #1 use case, the bread and butter, is managing Kubernetes deployments. It gives you just incredible control over complex microservices. But it's not just for apps. It's also used for total infrastructure management. We're talking provisioning cloud servers, networks, the whole shebang, with tools like Terraform. And that leads to a huge win, environment consistency. By defining your dev, staging, and production environments from the same Git repo, you finally kill that classic excuse, well, it works on my machine. And more, it's becoming the backbone of platform engineering, letting teams build amazing internal developer platforms that are both powerful and secure. And the real power of GitOps, the truly mind-blowing part, becomes clear when you talk about scale. We're not talking about managing 1 or 2 small clusters. Operations teams are using this exact framework to manage hundreds, sometimes even thousands of Kubernetes clusters across different clouds and data centers, all with total consistency and control, from just a few Git repos.
But here's the catch, and it's a big one. Operating at that scale requires discipline. Adopting a framework like this isn't just about installing a new tool. It's a fundamental shift in how you work. And honestly, this is where most systems break in production. Not because the tool is bad, but because the process is ignored.
Which brings us perfectly to our final core section, the pitfalls. Knowing the common beginner mistakes is the real cheat code to getting GitOps right. So let's talk about the traps that people fall into so you don't have to. Look, it really all comes down to this: the GitOps way versus the old cowboy way. The right way is making every single change through a Git pull request. It's auditable, it's reversible, and it lets the system self-heal. The wrong way is running a direct command like kubectl edit on your production cluster. It's untraceable, it's super risky, and it actively creates the very configuration drift that the system is designed to prevent. So let's break down the top 3 mistakes. #1, by a long shot, is making manual changes. You have to break this habit. It's a muscle memory that needs to be unlearned, because any direct change breaks the source of truth and it will just get wiped out anyway. #2 is poor repository structure. Just throwing all your configs into one giant messy repo is a recipe for disaster when you try to scale. And #3, and this is a subtle one, is ignoring drift detection. Remember, when the system overwrites a manual change, that's not a bug, that is the core feature. If you're seeing constant drift, don't just let the system clean it up. You need to investigate why people are trying to bypass the process in the first place.
All right, let's do a quick final recap. If you remember nothing else, remember this. With GitOps, Git becomes the single source of truth for everything, your apps and your infrastructure. The desired state of your entire system is always defined declaratively in version control. Then, automated agents work non-stop in that continuous reconciliation loop, making sure the real world always matches the desired world. And what do you get out of all this? You get huge improvements in reliability, security, and visibility. Your operations are no longer a black box. They become predictable, repeatable, and completely auditable from start to finish. We've covered a ton of theory today, but I know what you're thinking. You want to see this thing in action, right? Well, you're in luck. In our next explainer, we'll dive deep and see exactly how GitOps works with Kubernetes in practice, using tools like Argo CD to walk through a real-world deployment. If you found this breakdown valuable and you learned something new, please subscribe to the channel for more tech cheat codes just like this one. And sharing this explainer always helps us reach more curious minds. Thanks for watching, and I'll see you in the next one.